So this project is about creating an electric circuit with 2 buttons and 1 LED. The purpose of the project is to show that when both buttons are pressed, the LED turns on. If only one button is pressed, the LED will stay off. For this project, we'll be using the onboard LED wired to port 13 on the Arduino. So here we have the Arduino board and the solderless breadboard. There are 2 push buttons on the breadboard. The power to the circuit is provided by the Arduino board itself. You can see here the red wire plugged into the 5-volt pin on the Arduino. The red wire goes to the same row where the top terminal of the first button is located. The bottom terminal of the first button is connected to 2 wires. The yellow wire is plugged into pin 2 on the Arduino and configured as input. The pin is read by the firmware, which we'll go over in a minute, to determine whether the first push button is pressed or not. The second wire, the orange one, connects the first button to the second in series. As you can see, the orange wire is connected to the top terminal of the second button. The bottom terminal of the second button is connected to the green wire that goes to pin 3 on the Arduino, configured as input. Pin 3 is also read by the firmware to determine whether the second push button is pressed or not. Finally, the bottom terminal on the second button is connected to a resistor to limit the current in the circuit, and then to the ground using the black wire. As you can see, this wire is plugged into the ground pin on the Arduino, right there. Before going over the software, let's do a demonstration to show that the circuit does what it's supposed to do. So if I press the first button, the LED, onboard LED, remains off. If I press the second button, the onboard LED remains off. If I press both buttons, the onboard LED will turn on. So let's do it again. First button, off. Second button, off. Both buttons, on. This is the firmware that goes with the project, and I'm going to describe very briefly the functionality. So we define 2 constants, button 1 pin and button 2 pin, to indicate which pins we're actually using on the board as inputs. Those will be configured as inputs. And then we have the LED pin here, number 13, and that's the output pin. So in the setup function, we configure these pins as inputs, button 1 pin and button 2 pin, and as output, the LED pin. In the loop function, we basically read the state of each pin, and if they're both high, then the firmware will put the pin 13 in high state, which will turn on the LED. Otherwise, we'll keep it off. Thank you.